This first video will include 7 different ways to solve quadratics, how to solve equalities, but there will be a second video on how to use your graphing calculator, so make sure if you need graphing calculator help, you watch the second video. The first method of solving a quadratic is to isolate the squared term and square root both sides. In the first equation, the squared term is not isolated. Isolated means it's by itself. So we're going to start off by dividing both sides by 4. We get x squared is equal to 9/4. So now the squared term is isolated. I square root both sides. On the fraction I square root both the top and the bottom. I end up with x equals plus or minus 3/2. The second problem, I have to isolate the squared term first. That means you're looking right here on how you can get these parentheses that are squared all by themselves. I'm going to start by subtracting 2, resulting in 4 times x minus 3 squared is equal to 6. Then I'm going to divide by 4. Now I have the squared term isolated. X minus 3 squared is equal to 6/4. As soon as the squared term is isolated, you can square root both sides. The result is x minus 3 equals plus or minus the square root of 6 divided by 2. I add 3 to both sides, and the problem is finished. The next two methods of solving quadratics involve factoring. Problem number 2 is very easy to factor. You just think to yourself in your head, what multiplies to 8 that adds to 6? If I were to list out possible factors of 8, it would be 1 times 8, or 2 times 4. These are the correct numbers, so I factor as x plus 2 times x plus 4. And I just completed the factoring step, but now I have to complete the solving step. In order to complete the solving step, you have to ask yourself, either in your head or by showing work, what plus 2 is equal to 0? In this case, it's negative 2. And ask yourself what plus 4 is equal to 0? In this case, it's negative 4. If you're thinking about how this works, if you're multiplying two different numbers, a times b, to get 0, either a or b has to be 0. So the x equals 2 is one possible solution. It makes 0 in the first part of the factoring. The x equals negative 4 is the second possible solution because it makes the second part 0. After that, they get a little bit harder to factor. So in the first problem, one thing that's nice about it is it already is equal to 0. You cannot factor, let me write this down, you cannot factor to solve unless your quadratic is equal to 0. So in this easier example, I've got 2x and x. I need to think about what multiplies to 6 and x. It's either going to be 3 and 2, or 2 and 3, or possibly 6 and 1, or 1 and 6. But if I choose it so that the inside is 3x and the outside is 4, so inside terms in FOIL 3x, outside terms in FOIL 4x, and I make them both negative, that will give the middle term I need of negative 7x. So now I have to think about what makes it equal to 0. And so if I have 2x minus 3 equals 0, if you can look at that in your head and say 1.5, that's perfect. If you can't do that in your head, you're going to add 3 to both sides, get 2x is equal to 3, x is equal to 3/2. For the second part, I'm sure all of you can do that in your head. What makes x minus 2 equal to 0? The answer is 2. So your possible solutions for this quadratic are 3/2 or 2. In the harder example, the problem exists that you can't factor unless it's equal to 0. So for this problem, you have to take the 3x squared equals 10x minus 8, move everything over to the left side, 3x squared minus 10x plus 8 equals 0, then work out the factoring. I know it's going to be 3x and x. I don't know if the last term is going to be 2 times 4 or 4 times 2 or 1 times 8 or 8 times 1. But if I choose the 4 here, that makes the outside 12. And by choosing the 2 here, that makes the inside 2. And if I have a negative 12 and a positive 2, that will give me my negative 10 as the middle term. So the solutions to this equation are x is equal to negative 2/3 and 4. And if you don't know where the negative 2/3 came from, I just took 3x plus 2 equals 0. I moved the 2 over and divided by 3. I just did that step in my head. Another type of factoring is recognizing differences of perfect squares. In this case, if the first and second term are both perfect squares, they're always going to factor in the form a minus b times a plus b. So for this problem, if I recognize it's a perfect square, I can factor it as 2x minus 3 times 2x plus 3. Ideally, you're going to look at this in your head and say, well, that is 1.5, and the other one is negative 1.5. And if you can't do that in your head, I did it by taking 2x minus 3 equals 0. I moved the 3 to the other side, so I get 2x equals 3, divide by 2, and get x is equal to 3/2, or 1.5. The fifth method of solving quadratics is completing the square. Completing the square was one of the more step sort of heavy techniques you learned last year, but you're going to need it a lot in pre-calculus for solving, and so it's a good technique to know. So the first thing you do is you take the x squared and the 6x, but instead of making it equal to 0, I move the number to the other side. Then I look at this number, which is the b term. I take the b term, which in this case is 6, I divide it by 2, I square it, and then I add that number to both sides. So for this problem, 6 divided by 2 is 3, 3 squared is 9. I'm going to add 9 to both sides. The beauty of the completing the square step is the left side has now become a perfect square, and I can go back to my first technique for solving equations, which was isolating the squared problem, taking the square root of both sides. You get x is equal to, or x plus 3 is equal to plus or minus the square root of 19. I move the 3 over, I get x equals negative 3 plus or minus the square root of 19. In the next example, there's a rule that says you can't complete the square unless there's no number in front of the x squared. And so you can either do this by factoring it out or dividing it out. It's up to you, and both ways can be really tricky when you're dealing with fractions. I'm going to divide it out. And so I have x squared minus 1/4 x, and I'm going to take the 2/4 and move it to the other side and reduce it to negative 1/2. So I divided out the leading coefficient, I moved the number to the other side, and I'm still going to do the same step. I'm going to take the middle number, which is right here, I'm going to divide it by 2, and I'm going to square it. But in this case, the middle number is 1/4. If I take 1/4 and divide it by 2, I get 1/8, and if I square 1/8, I end up with 1/64. And so as you can see, you start dealing with some pretty big fractions. This will be x squared minus 1/4 x plus 1/64 equals negative 1/2, which I'm going to write as negative 32/64 plus 1/64. The beauty of the completing the square step is the 1/64th that's right here is always going to be the number that you divided in half before you squared it when you factor it. So this will be x minus 1/8 squared is equal to negative 31/64. I now have the squared term isolated, so I'm going to square root both sides. So x is equal to 1/8 plus or minus I square root 31 over 8. Yuck. If it's that hard to complete the square, you might as well use a quadratic equation and save yourself some time and effort. So the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So for this problem, the first thing you do is make it equal to 0. If it's not equal to 0, you can't apply the quadratic equation. After making sure it's equal to 0, your next step is to identify a, b, and c. For this problem, a is equal to 4, b is equal to negative 3, and c is equal to 2. When I fill in b, I'm always going to fill in the opposite, so the opposite of negative 3 is positive 3. When I fill in the b squared term, I'm always going to make it positive because when you square a negative, it's positive. And if you get used to filling that in as the b term squared, 9, rather than, well, in this case it's 9, but 9 rather than negative 3 squared, you'll save yourself a common mistake. So it's 9 minus 4 times 4 times 2. This first 4 is from the equation, but the second 4 is from the a value, all over 2 times a, which is 8. So I end up with x is equal to 3 plus or minus the square root, and then I have to think about what 9 minus 32 is. And yeah, it's late. I'm not thinking very well. Negative 23. All over 8, and that separates into 3/8 plus or minus I square root 23 over 8. The seventh way to graph is actually going to be on a separate video under using a graphing calculator, so you'll have to look for that one on my website. But we're going to have a few problems on the assignment that have you write an inequality as an absolute value. So you need to think about where it's centered and how far it is from the center. And the best way to do that is to graph it. If I'm going to graph this first inequality, I'm going to subtract 3 from both sides. I get that x is between negative 1 and 3. When I look at that on a number line, here's negative 1, 0, 1, 2, 3. These appear to be 4 apart, so the center is right here at 1. It's centered at 1, so I'm going to have the absolute value of x minus 1, because just like circles, I always use the opposite. And then it's everything that's within 2 of 1, because I go 2 to the right, and I go 2 to the left from each side to get to the edges. Here's another example. I need to look at the graph first. You know, multiply everything by 2 to get rid of the fraction. So 10 is less than or equal to x minus 4 is less than or equal to 16. If I add 4 to all 3 sides, I get that it's everything between 14 and 20. If I think about what 14 to 20 looks like on the number line, they're 6 apart, and so the middle should be at 17. If this graph is centered on 17, then my absolute value equation will be the absolute value of x minus 17, and it's everything within 3 of the absolute value of 17, because I have to go 3 to the right and 3 to the left from that center.